VLPSos here. This is a video lesson for Python programming, Palette. I've started a code file with stub1 to give me the basic structure of a graphics program with Pygame. This lesson is going to be about making a file that we can import into a stub like this or a program that we're writing. And that file is going to contain a dictionary which contains all of the colors that we would use in a graphics program. In this stub and previous, we have defined colors in a section before a frame loop. These are some very common colors, and we have descriptive names in capitals as variables to represent those color tuples. What we're going to do is we're going to move this information for color tuples into a separate file and then import our colors at the beginning of the stub or at the beginning of these programs. And we're going to call that file palette, as if it's a palette of colors. These are the colors that we're going to put into that palette file in the beginning, and we could create more. The palette file, which will contain our colors, then can become something that evolves. We can include colors in it, and we can share that file in order to share the colors that might be a part of our programs or a large group of programs. We begin by making a separate file and calling it palette. I have here on the left side of my screen a window that is the operating system window of the folder that contains the code file that I'm writing and displaying here and this new file that's called palette. If we open up that file, you can see that I've prepared it with some comments. I have the title of the file at the top. I have some sections which will contain different colors, gray tones, additive primaries, subtractive primaries, some other common colors that are not primary but very often used, and then a section for new colors that can be added by you. I also have a comment here that is the structure of how we would make a new color. And we'll get to that in a moment. These colors I'm going to copy and I'm going to put as notes into that file. We need to adapt this color information to the new way that we're going to do it. And we can then erase them from our program stub. I'm going to modify this. Colors are now being imported from palette.py. If that's the case, then I need to import at the top from palette, the program file, import palette, which will be the variable whose value is a dictionary, and that dictionary will contain our colors. So that's what we have to prepare in the palette file. We do that by making an empty dictionary first, called palette. So palette is the name of the file that contains the dictionary called palette that we'll be importing. So how do we put colors into a dictionary? We refer to the dictionary's name, and then we need a key. The key is going to be the name of the color. In this case, it'll be a string, and the first color that we're going to add to the dictionary is white. But we're not going to put a K in front of palette. And that'll be equal to then the tuple that stands for or represents the color white. Full red, green, and blue. 255 values. So a color tuple has been added to the palette dictionary with the key white. If we then wanted to use white in our program, we would import the palette dictionary and then refer to that color tuple by using the dictionary name with that key white. We're going to put all of these colors into the colors that we had before, this block. We're now going to put them in the dictionary. To do that, we could get this generic structure that was supplied as a comment and paste it several times. The gray tone colors are going to be white and some grays and black. Black is 0, 0, 0, and we could, for some purposes, make a few grays. Light gray, gray, and a dark gray. Oops. The keys are descriptive names of the color. We'll get a gray anytime the red, green, and blue values are equal. So a light gray is going to be red, green, and blue of equal measure, but very high, like 220 each. A gray right in the middle of the range would be around 140 or 135. And a dark gray is going to be all equal but low values, and black is, of course, no red, green, or blue. The additive primary colors are the red, green, and blue. I'm going to copy the structure, 3 for the additive primaries, 3 for the subtractive primaries, a few for common colors, and we'll move forward with that. Additive primaries are called red, green, and blue. Subtractive primaries, magenta, cyan, yellow, and some common colors, orange, purple. What else have we prepared? And a brown. I can cut and paste these tuples for colors that I've already prepared. Then get rid of the old color information. Pure red, 255.00, pure green, 0.255.0, and pure blue, 0.0255. We've prepared a palette dictionary with many very useful colors, and we can add many more. The comment will help create new colors, and we can list them under comments in any groups that we wish. This is going to be saved. I'm going to run this file just to make sure there wasn't any errors. It doesn't show anything, but it doesn't do anything because this palette file is now a resource for the other programs in this stub. It's been imported at the top. Now, if I ran my stub program, there ought to be an error because black is no longer defined. We're not using colors referred to as in capitals. So a screen fill, which erases the screen, the argument, which is a color, then needs to be changed to this new way of referring to our color tuples. From the palette dictionary that was imported, in parentheses, the color black. We're still using a descriptive word for our colors. Many programs use many colors. So part of being referring to colors this way and importing a dictionary is that we no longer then need a big code block which lists all of our color tuples. We just have one line to grab them all in a dictionary. And of course that file can be shared so we can share the colors that we're using. We're going to view these colors. We're going to take the strategy of filling the screen with a color but slowing it down by basing it on some processing speed. We will do that by making use of frames. If frames is greater than or equal to frame change, then frames will be reduced by frame change, and we can proceed in this code block to do something like fill a screen with a color, which means that we need to increment frames, add 1 every time the frame loop iterates, and we need a variable called frame change whose value is how many frames get counted before we trigger the effect. This value will be 2000 on this computer, which is a fairly fast CPU. The effect that we are going to want to do periodically when the frames count up to 2000 is change the color. So we were going to do that by a color index. We're going to index a list of all of our colors. If we're going to index a list of all our colors, we need a list, and we have all of our colors in the palette dictionary, but we can create a list of those colors by making the variable equal to the list function, which what we are making a list of is the palette keys. And we will take a look at this color list. To understand how our color list was created and what's in it, let's iterate through it after we create it and print. We can see in idle that we have a print of all of the keys of the dictionary of palette, which are colors. We're going to use that color list as fills for the screen. So we will continue. When counting our frames has triggered this code block, it will increase the color index by 1. We're going to use the color index to fill the screen from the list of colors. We have to make sure that if we're adding to color index, it does not get to be higher than the length of the list that it will index, or it'll break our program. So if the color index has gotten to be greater than or equal to the length of the color list, then we're going to set it back equal to 0. Again, this is making sure that the integer that we're going to use to index our list of colors does not get to break our program by becoming too large. So once it gets to the end of the length of that list, it gets reset to 0. So we'll cycle through our color list. And now that we have an index, we will fill our screen. Every frame. We're going to fill it from the palette dictionary. We will grab the color from the color list that has the current color index. Let's test the program. Looking for errors. Frame needs to be plural. It's plural there. Let's take a look again. So as the frames get counted, we are cycling through all the colors that exist in the color list, which was made from the palette dictionary. There's our orange, our purple, and a brown. This screen fill line is fairly sophisticated, so I'm going to add a comment to make sense of its parts. A reminder that palette is a dictionary of colors, and the dictionary is structured with key and values. And that is the name of the color is the key in the dictionary, and the color tuple is the value. Color list is a list of all the colors which are keys in palette. And we made that before the frame loop. Color index is an integer used as the index or position in color list. Some comments to explain this rather sophisticated argument. Now you have seen how something as common as a list of colors can be managed and included in your programs as a separate file. In this case, the file created a dictionary. This is the palette file. The file created a dictionary of colors that can be imported and used in any program you write. Add to the palette file a few colors of your own that you like and are likely to use in the graphics program in the future that you write. Make sure to give them unique but descriptive names. A collection of colors will be compiled into a shared palette.py file. Have fun.